Let f be a differentiable function such that f2 is 5, f prime 2 is 3. If g is the function defined below, right here, what is the value of g prime 2? So simply we're going to take the derivative of this, plug in 2, and I bet these will come up to be important as we proceed in the problem. So let's start with g prime x. Looks like a quotient rule yet again. So the derivative of x is 1 minus 2x. That's the numerator. We're going to leave the bottom, f of x, minus, leave the top, so be leaving the x minus x squared, and take the derivative of the bottom, which should just be f prime x. And that's going to be all over f of x all squared. Okay, so that's the derivative. Kind of funky looking. Now I could simplify, but why? Because our goal now is to simply plug in 2. So we have 1 minus 2 times 2. And then we have f of 2 minus 2 minus 2 squared minus f prime 2. That's all over f of 2 squared. Okay, so let's clean this up some more. So f prime 2 is equal to 1 minus 4, which is negative 3. F of 2, what's f of 2? F of 2, it says right here, is 5. So I'm going to replace this with 5. Sweet, we have 5. Minus, okay, 2 minus 4 would be negative 2. F prime 2, what's f prime 2? F prime 2 is right here, is 3. So I'm going to replace this with 3. Okay, that's all divided by something squared. So what is f of 2? F of 2 again was 5, so I'm going to replace that with 5 again. And now we're going to simplify this. This will be negative 15, ends up being plus 6 all over 5 squared, which is 25. So that would be a negative 9 over 25. So what is the value of g prime of 2? So g prime of 2 is equal to negative 9 over 25. The table below gives the values of the differentiable function f and g and their derivatives at x equals 3. If h equals this, then what's h prime 3? So this table, we talked about it in a previous problem, but let me describe what this table is basically saying. This table is basically saying put 3 into each x here. So let me write that out. This is saying f of 3 equals 2. This is saying f prime 3 equals negative 1. This is saying g of 3 is equal to 5, and this is saying g prime 3 is equal to 4. That's what it's saying. So the table can be tricky until you get used to it. So we're going to take the derivative of this and plug in 3. Now here we go. So the derivative of h is going to be a quotient rule. So the derivative of 2f of x is 2f prime x. That would be the derivative of the first piece, times leave the second piece, I'm going to change that, minus, leave the 2f of x, and then we're going to, from there, take the derivative of 2 minus g of x, which would be negative g prime x. So, again, the derivative of this is 0 minus g prime x. And then don't forget, which is very common, people forget to divide by the denominator squared. Okay, so our next step is to plug in 3. So when we plug in 3, we have 2 times f prime 3. Okay, that'd be 2 minus g of 3 minus 2 times f of 3 times negative g prime 3. That is all over 2 minus g of 3 all squared. So what do we get with all of this? Well, f prime 3. What is f prime 3? Let's replace f prime 3, f prime 3, f prime 3 is negative 1. So can I go over here and replace that with a negative 1? All right, what's g of 3? g of 3 is 5. So can I replace this with a 5? F of 3. f of 3 is 2. So can I replace this with a 2? And g prime 3 is 4. So can I replace this with a 4? And g of 3 is 5. So can I replace that with the 5? So let's see what we get. We get 2 times negative 1, which is negative 2. 2 minus 5, which is negative 3. We have 2 times 2, which is 4, and a negative 4. All over negative 3 squared, which would be 9. So let's take the next step. That would be positive 6 plus 16 all over 9. 6 plus 16 is 22. That'd be over 9. So my answer to this would be 22 over 9 is the slope of h at 3.